everyone, welcome back for lesson 1.2. Today you are going to need your Springboard book open to page 8. You are going to want that formula sheet that you hopefully kind of started yesterday, or your vocab sheet, whatever you have that in a notebook or on a sheet. You're definitely going to want your graphing calculator today, and then a pencil and a highlighter. Now, before we begin, I'm going to apologize in advance if you hear a crying dog in the background, because Bo has decided to just not like today. So, fair warning. Now, today we're focusing on arithmetic sequences, specifically sigma notation to represent a series, and then moving into arithmetic sequences and finding partial sums of our arithmetic series. Okay. Now, we're starting right off here with some vocabulary and our good pal sigma notation. Now, all sigma is, it looks intimidating. You see this Greek letter, you're like, what is that going to be? All sigma means is sum. Okay, add your values in your sequence up. You're taking those commas and you are changing them to plus signs. That's the difference here. So notice with sigma, we have a starting term there. We have an ending term that we are going to stop at up top. And then in the parentheses is the rule of the sequence that we are plugging into. Constant or otherwise. So if you look at part A here, we are starting with term 1, and we are adding up term 1 plus 2 plus 3, 4, and all the way to term 5, and that will be your the way you get your final sum. The difference here in part B, however, is you're starting at term 3 and you're adding up term 4 and term 5 with it. Okay, so we're only adding up those three terms in our series. Okay. So example A walks you through how we would do this. Again, be careful of where you're starting. In this case, it's term 2. So you're going to plug in and find those terms 2, 3, 4, 5, 6, and 7. So we see that ends up being 7, 9, 11, 13, 15, 17. And then all sums together is a value of 72. Now moving on to page 9, we're going to see a couple problems here. Biggest thing you need to start with is looking at what is the difference between A and B and how is that going to affect our summations. Well, both problems are starting at term 1 and ending at term 4, but what we're plugging into to get the values in our series is different. So notice here, we're plugging into 5j minus 1. So that's going to be 5 times 1 minus 1, and then to get term 2, we have to do 5 times 2 minus 1, oops, and then 5 times 3 minus 1, and 5 times 4 minus 1. Now, that is going to give us values of, get that all together, 4, 9, 14, and 19, for a total of 46. The lack of parentheses in part B is telling us that actually our rule is coming right here. It's just 5j. So when we plug in this time, we're plugging just into 5 times 1 plus 5 times 2, 5 times 3, and 5 times 4. And then at the very end, it's the minus 1, since we did not include the parentheses around it. So really it's just 5 plus 10 plus 15 plus 20 minus 1, which this time is 49. Okay. Last but not least, part C also needs some care. It is different because we are starting at term 0. Yes, that is a thing. So we're going to start at 0 squared plus 1 squared plus 2 squared plus 3 squared. So we're adding up 4 terms, but we're starting with n being 0, k being 0, x being 0, however you want to look at it, for a total of 14. Now, we spent some time in the previous lesson talking about finding our rules for a sub n, and we chatted yesterday that in order to find this rule here, notice each time we are going up by adding 4, which means the coefficient here is going to be 4n, and then in order to get 1, 4 times 1 is 4, so we would have to subtract 3 in order to get 1. And as we test out other values of n, we see we get these other values in our sequence. Well, the problem wants us now to take this and put it into sigma notation. So here's our rule. But to officially be in sigma notation, we also need to take into account our starting value, which we're going to say we started at term 1, and then we're summing up 1, 2, 3, 4, 5, 6, and 7 terms to get our final answer. All right. Take a moment on your own to try number 3. You should have gotten that we are again summing up, similar to the previous problem, 7 terms, and it ends up being a total of 168 push-ups, right? Now, the reason I wrote that out is because I also want to show you the beauty that is your calculator. Now, some people are really anti-calculator. You need to know how to do all this by hand. That's not my style, so I want to make sure you know how to use the devices at your disposal. So those of you that have a newer calculator, like a TI-84 with pretty print built in, these instructions are for you, and then we'll go over the older calculators as well. So what you're going to notice is in order to do this, what you guys are going to have to do is you're going to start by hitting alpha, then window. You're going to scroll down to number 2, and you are going to fill in accordingly each of these pieces. So I would just call you rule X instead of N. Just have to go to the calculator. And then again, our rule for just testing out that problem before. Notice we got our 168. Now, if you have an older calculator, put this in classic mode, like myself, I have a TI-84 from high school, but it doesn't have pretty print on it. We have to work a little bit harder. You have the second menu, stat, scroll over to the math menu, and you're going to scroll down to summation, option 5. Then you're also going to go back through, and you're going to scroll back after you hit second stat, scroll over to the apps. Again, you're going to select option 5. And this is where you're going to type in the expression, the variable. Again, I would just replace n with x. And you're starting at term 1, ending at term 7, going up 1 at a time. You're going to paste that in. Voila. There is your final answer. So just press enter at the end there. Now, there is this whole piece, and if we were in class, I would show you through how we can come up with a formula to shortcut the summations, because as the more and more terms we get, we're not going to want to constantly keep doing these summation problems by hand. And this is one of the few times where we're going to say, thank you, remote learning, and I'm just going to save us some time and not go through this entire summation. But what is important here is that you notice here this formula. What's basically happening is the summation formula for an arithmetic sequence, which we'll talk about in a second, when you're going up by that constant value, is you're going to take the number of terms divided by 2, and you're going to add that. You're going to add that to your first term, and then your last term, whatever term number you ended on, and that's going to be the total sum. So notice here, for instance, like with number 6, our first term was 3, a sub 1 is 3, and then we would have 6 plugged in for n, and our last term number here at 6 was 13, plug that in there, and together that equals 48, that summation of points, okay? Now, this formula is really, really handy. Why? Because it can help us solve for some things. So, for instance, if we go back to this, we want to know how many DVD rentals it's going to take us to get a freebie from our Fantastic Flicks. Now, back from last lesson, we are going to get a free DVD after we obtain 100 points. But how many rentals is it going to take to get that summation of 100 points, right? We have no idea, right? Because we don't want to have to spend time adding all those together. So using our chart here, we know the first term was 3, okay? And we can plug that in then for p sub 1. Now, p sub n we don't know, but we do know that the terms each time, the rule was, p sub n in general, was 2n plus 1. So if we start simplifying here, I hate fractions in the denominator. So what I'm going to do is I'm going to multiply both sides by 2 to get rid of that. And so I'm just left with n. And I'm going to combine inside here this to be 2n plus 4. And if we distribute that n through, we get into 2n squared plus 4n. And I'm going to bring this 200 over using subtraction, so that hopefully this is jarring in your memory. Oh man, looks like we are going to have to solve, aka do some kind of factoring quadratic formula. Now to simplify a little bit more, everything here is divisible by 2. Notice we have a least common denominator, or greatest common factor between them of 2, and divide everything by 2, we end up with n squared plus 2n minus 100. Now unfortunately, there is no really nice, pretty integers that multiply to be negative 100 and add to be 2. So what our best bet here is actually going to be is using our old pal, the quadratic formula, okay? Which goes back to our good song, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, right? I always like to say it to like Pop Goes the Weasel. Okay, so in this case, as we start plugging in, what we have here, clear this out, we would have a, b, and c here. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay. So as we plug this in, what you're going to notice is we have negative 2 plus the square root of 4 minus 4 times 1 times negative 100. And then I'm going to divide that by 2. One of our factors is going to be 9.05. And the other factor, when we do the subtraction from the quadratic formula, over change this to subtraction and divide by 2. What you're going to notice is we have a negative value, negative 11.04. Now, in the context of this problem, kind of going back to what we talked about yesterday, there's no such thing as a negative amount of rentals. Okay, only positive numbers work. And in fact, for the context of this problem, we have to round up to 10 total rentals, since we can't do 9.05 rentals. Okay, so our total here is it's going to take 10 rentals. Now, this next portion, I promise you, is much easier. Here we want to know, okay, we have a total of 260 DVDs, and we know that there are 8 in the top row. We want to know how many there are going to be in the 10th row. So what we know right now is that the sum of those 10 rows is going to come up to 260 DVDs. And we know that 8 is the value in our first row. The question here is how many DVDs are going to be in our 10th row? So if we plug into the formula s sub 10 plus 10 divided by 2, first term plus last term, which in this case there are 10 rows, last term is 10, we can substitute in the 260 here for s sub 10. We can substitute in for a sub 1, 8, and solve. So we have 260 equals 5, 8 plus a sub 10. Well, I personally like to divide everything by this coefficient out front. That's how I personally would rather solve it. You do you. but you should get 52 equals 8 plus a sub 10. This was canceled. And last but not least, when you subtract over, we're going to find out that there are 44 DVDs in that 10th row. All right, now take some time and have you go through and try 7 parts A through D on your own. All right, final pieces here, okay, bringing it all together. Now, why have we been doing all this? Well, kind of this is bringing us to finally talking about our arithmetic sequences, right? And arithmetic sequences are those values that are going, as we talked about yesterday, up or down, adding or subtracting by a constant value each time. Now, we have talked a lot about being able to find those expressions by hand. There's also now a foolproof formula you can plug into, okay? And again, a sub n is the term you are looking for. A sub 1, what represents your first term, and then n is term number. D is that constant difference, and the constant difference is that value that you're going up or down by each time, so positive or negative, kind of depending, okay? Now, going back to what we talked about yesterday, these values going up consistently, P sub n, they're arithmetic because there's that common difference of 2, positive 2 each time. But F sub n is not arithmetic because it doesn't have a constant value. We're going up by 5, but then we're going up by 7, but then we're going up by 9. That's not a constant value between those consecutive terms. Right. The last page then is just kind of summing all the things that we talked about today. So we started talking about sequences, just a pattern laid out, arithmetic. In this case, we're going up by 1 each time. When we change this to a series, again, all we're doing is taking those commas and making them into addition signs, right? We're adding them up. This is the series. A partial sum then is when we're only adding up a specific value of our series. So in this case, we're adding up term 1, and then sum of the first 2 terms, sum of the first 3 terms, sum of the first 4 terms, right? Those are our partial sums. Okay. So series versus sequence, commas versus addition signs. All right, now the rest of this we'll talk about in class tomorrow with practice-wise, but just to summarize some things for today, if you're adding to that formula section and vocabulary, these are definitely the pieces that I would have written down for today, especially these formulas because they're going to come up. Now we call this the explicit formula because when we are able to plug in, if I want to find the 59th term, I just have to plug in 59 for n and boom, and of course the other pieces as well. But I'm going to be able to find that term. I don't need to know the term prior to it necessarily to get it. That's why it's explicit. Later on, that's going to become important in activity 3 when we start talking about recursive. All right. Thanks for listening. See you in class.